Now I start recording the first videos. You can see in the question is premium. So hopefully you have the premium account, and then you can open this. This question is minimal JSON swap to make a valid array. And you are given zero index integer array nouns. Swap of adjacent element are able to be found on the noun array. The valid array means following condition. Okay, it's a valid array mean the following conditions. So largest element, any of large element if there are multiple. So here maintain have multiple is rightmost position in the array. The smaller element, any of smaller element if there are multiple, you can see. So it can have duplicate smaller elements in the array and left position in the array. A return minimum swap required to make nouns a valid array. You can see here input example like perform. So here we can see. So we need to care here. Here already told us it have some multiple largest elements. So so here we know two obviously the two the five is the largest element, right? By here duplicate. But here already say here's an rightmost position in the array. So here we need to pick one position. Which one? So we need to put the rightmost position, right? Because here we just only swap two position and then the five will in the last position, two step, right? So you can see here the five the originally here two five now three 5 swap with the 3 so you can see here and then 5 one more time 5 reaching the last position and then 1 need to swap to the leftmost position, right? So that's why here you can see here has 6 swap. Now here just only single two condition. So I would say this question is not too hard, just a little bit tricky. So now I will show you how to. So there are two test case we only consider. One test case is for example, this one is first let me maybe 1 and the 5, maybe 5, 3, 3, and then here's 2. Okay, to make it simple. This one is first test case. The second test case, so you can see. So doing this question, we just divide this array into two puzzle, two partition. So you can see here we know the maximum number in the right partition and the smaller animals in the left partition, right? So this first case. So here we just swap this one to here. So just one step, right? Now here we cannot start from here. We cannot choose this five because we need to choose the most rightmost position. Because if we pick here, we need to take one swap, two swap, three swap, here three step, right? If we pick this one, because this is 5 dpk, right? If we pick this one, obviously it's just two step, two swap, right? So we need to, because the question said we need to find the minimum swap. So we cannot pick a bigger one. We need to pick the rightmost position, right? And then, so it's simple. Now, so it's first test case. We just add, now his formula is the, so index is 0, right? So index 1, we just if this condition, which is at the 1 plus the length minus this position 0, 1, 2, 3, 3. So when the length is 5, so first condition is the here is for the minimum one. How many swap we do for the smaller element, and then here is 5 minus 3. Here the formula is for the rightmost position to the right to the end, right? So here 2, 1 plus 2 equal to 3. So here which is use the 3 swap to get the 3 swap is a minimum swap. Now second position is we also do the same thing, just divide this array into 2 partitions. So but in the one test case is 1 5 1 3. I just make it simple. Now we divide these two part, right? Now we know one is obviously one is the smaller element, so we need to treat to reach the leftmost, so that can be used 2 step, right? 2 swap, and the 5 to the last position also need to 2 step. But actually no, here it's not totally here. We know here is 4, right? Actually no, it actually we only swap 3 times. So it's we need to actually here it's not 4, it should be 3. I will show you why. Here, so we know 5 need to go to right. So now we need to change in this swap need position for this one, right? So 1 come to here. So here you see here 5 need to go to this position, 1 need to go to this position. So actually needs should be 1 plus 1, right? No, actually when we swap 5 to the 1 where the position is, so actually it's just only take one swap, right? And what it just take one swap, right? And then here is 1 5. Now here we know 5 in the right portion and 1 in the left portion. So now we just do the previous. It's now the test case become the previous test case, right? So just doing the same thing. We just calculate the swap and calculate the swap. So here's just saying, okay, just take one swap here, 1 to leftmost, just take one swap. 1 plus 1 plus 1 is 3. So it's just a tricky one. So there's 2 conditions. So hopefully you can understand. So I draw this diagram a little bit messy. So hopefully you can understand. Now let's quickly go through the coding. So here, so we need to check the length. So you can see here in the constraint. Here start from 1. It is possible the text can only contain 1 element. So if we just 1 element, we know we don't need to do any swap, right? We don't need to do any action. So just return 0. And now here minimum in there, maximum in there. Now this why we do here? So we need to know where is the position. What is the position of the maximum element? Here maximum element. So that's why here we need take care here. We need to use the equal sign because we need to find the most rightmost position, right? We need to find this one. We cannot get this position. We need to get here. We need to get this one position 5, and then so this one we need to equal. If they are same, if the both element have the same element, so we need to find which one is which one is produced close to the most left rightmost, right? And then here is doing the same thing because we need to get a first position, not the alternate first. Now, when we get a position, we need to check which condition is. Just now I mentioned here that two test cases, right? Two conditions we need to consider. The first one, if the minimum less than maximum index, so it's the first condition. And we find the position in the left portion and the maximum in the right portion. So we just index plus the length minus index minus 1. Now we will get a result here. Here is the second condition. In second condition, that's why we need to because here already minus 1. We know the second position not only 2 plus 2 is 2 plus 2 minus 1, because you can see here here we reduce one swap, reduce to one just only one swap for both elements, and then here soon minus 2. Now let me submit it. So you can see in the B 91%. So now time complexity is B of n. N means just loop through the array only once. The space complexity is constant time. I didn't use the extra memory, so that's why. So thank you for watching this video.